Hello YouTube, I'm back in the garage, and in this video I will attempt to do some thread milling. Got this little cutter here, had it for almost a year now I think. Never used it. Pitch is 0.8 millimeters, which is good for M5 I believe. So the plan is to make a lot of holes, 4.2 millimeter holes into this steel plate here, then to thread mill them. But since I haven't done it before, I thought that I would start off with some practice here on this steel piece. I think I will start off with boring out half a hole, if you understand what I mean, and then try to thread mill it and see how the pitch will look like. So let's give that a try. Well, that went a bit faster than I expected. Right, so as you can see I had to make some attempts and had to adjust something called pitch diameter offset. That one was set to 0 by default in Fusion, and it's hardly engaged at all. So then I set it to 0.4 and it's starting to engage a little bit, and after that I changed it to 0.8, which should be the correct setting I think. And now it looks like I got some decent threads here actually. Feels like they work. Well, that didn't sound too good, but how do the threads feel? So the threads seem to work pretty okay, and they also look very good. However, I'm not satisfied with the drilling. It didn't sound good at all, so I think the feed rate that I used was far too low. I think I need to triple it. Problem is though that this spindle here goes from range from 7,200 to 24,000 RPM, and according to manufacturer, optimal RPM needs a pretty high feed, which results in a power needed of almost 1 kilowatt, and I don't think that this one will be able to output 1 kilowatt at that low of an RPM. But let's do some testing. I got a fairly cheap drill mounted to do some testing with. As you can see, the spindle seemed to be far too weak. Stalled instantly. So now increased packing depth to 2 millimeters. Let's give that a try. So this was the drill that I used for the testing. This one is from Garant, and it's 4.52 millimeters, so it's kind of an odd dimension. That's why it was cheap, I suspect. But for making the holes in the steel plate, I will need a 4.2 millimeter drill, and got one brand new here from Sandvik. These ones are kind of hard to find, so that was why I didn't wish to do any experimenting with this one. Or they are not hard to find, but they are hard to find cheap, and I like to buy cheap. So yesterday evening I collected some cutting data or recommendations from Sandvik, their drills. So here we have the 4.2 millimeter one, which I will use. So they recommend a spindle speed of 85-60 and feed rate of 1500, and that will need almost 1 kilowatt of power, and I can't my spindle won't handle that. So you see what happened when I made the first test drilling with this one. It stalled. So it's about balancing what the spindle can do and then as high of feed rate as possible, and not trying to break the drill. So I'm thinking that I will back this one down to back this one down with 1/3. So I will go for 1000 in feed rate, I think. Right, let's give it a try. No one remembers a coward, as we say in Sweden. Shouldn't have touched that one. I stole the spindle. Tried to reduce the RPM just a little bit, and it stalled. Well, hopefully I didn't break the drill, but I'm sure I did. I just wanted it to sound a bit better. It felt like the spindle was going a bit too fast, but it's everything about balancing. So it seemed like I was just on the limit what the spindle could handle. Right, let's make a new attempt and try not to touch anything when it works. Guess I'll have to have the RPM like this. I see an issue coming here. So here are the settings that I'm used in case anyone is interested, and that seemed to work very good with 8600 to 700 RPMs. Lower than that, spindle will stall. And yeah, the feed rate I used was 936, and if we type 8600 here, it will give us a surface speed of 113, so that's a bit too high. So the drill seemed to be in great condition, even though I stole the spindle, so that was nice. Would have been very boring to have destroyed the drill. Right, so the hole's now chamfered a little bit, and I think it's time to try some thread milling out. So let's give it a try. So now test mounting a screw in each hole, and I think that I should have made the chamfer a bit deeper, since it's a bit tricky on some holes to find the threads. So now test mounted all the screws, and the good thing is that all of them fitted. This middle row here, I didn't thread mill these holes, I tapped by hand last week. But an interesting observation is that most of them felt a little bit tight. I had to use a little bit of force to get them down. Up here though, these ones felt perfect, and I think it got something to do with that I changed the RPM and feed rate here to what must have been the optimal feed rate or RPM, and I changed between 11,000 RPMs and 14,000, but I can't remember which way I changed it here. And I also adjusted the feed rate a bit up and down. I didn't record the whole thread milling cycle, otherwise I could have checked the video. But apparently feeds and speeds seem to be critical when doing thread milling. I'll also show you in Fusion. So this is what the cutter looks like, and the settings that I typed in here. And when it comes to the feeds and speed, I went with 11,000 here. So that will be 134 in surface meters. And feed rate, lead in 500. And first I took a pass of with this one set to 0.8, but the fit was a bit tight. I don't really know what this one does, but I increased it to 0.9 and it felt like it got a bit better. So if you want to learn thread milling, I think there are better channels to go to, but this is just me documenting and doing some experimenting, trying to learn. I mounted a piece of 4140 round stock here, and the plan is that I will make a chuck adapter backplate for monetization. So tomorrow I will drill the whole pattern, and then I will mill out the pocket so that this one can sit onto here. Then I will mount tool holder here and try to turn it through and to mount the chuck. Here we got the chuck. It's from Pratt Bernard. Also got a lot of Sandvik Capto tool holders and some Capto clamping units as well that I plan to use when I make the turret. But for now I'm thinking about only taking one and mounting it, just to try the lathe out a little bit. I never used the lathe and been looking forward to for over a year now. Well, some of you might have noticed I activated ads now on YouTube, which means that I will get a small amount of money paid out now and then, and can share some info on that in case anyone is interested. So I think I had it activated now for 6 days and totally generated about 15 bucks. So a bit below $3 a day, which isn't super much, but still it will almost be 100 bucks a month. And for 100 bucks you can buy some second-hand cutting tools, and that is very appreciated. So huge thank you to all the ones that have been pressing thumbs up and subscribing and commenting. It really helps me out with continuing with this hobby. Take care and see ya.